Alright, so today we're going to be finding imaginary solutions with the quadratic formula. Now, before I go into how to do this, I just want to give a brief review of what imaginary numbers really are. Alright, so let's start with the square root of -1. Now, the square root of -1 really doesn't exist. And it's what we call an imaginary number. And so what we do is when we have a negative number inside a square root, what we do is we break it up into the square root of 1 times whatever the square root of that number is. And we denote this square root of -1 as I. And I comes from the word imaginary. Alright, so now that we know that, now that we know how to rewrite negative numbers underneath radicals as the square root of -1 times the square root of that number, what we're going to do is we're going to do a series of examples to show how to find imaginary solutions with the quadratic formula. So let's get started. Alright, so today our first problem is x squared plus 4x plus 13 equals 0. And so what we're going to do is we're going to use the quadratic formula. And to give a little refresher, we're just going to put this in the corner here. So the quadratic formula is x equals -b over 2a plus or minus the square root of b squared minus 4ac over 2a. Alright? So now what we do is we just plug these values into the quadratic formula. So a is equal to 1, b is equal to 4, and c is equal to 13, right? Because the standard generic quadratic formula is ax squared plus bx plus c, all right? So now we're just going to plug it in. So we get negative b, so this would be 4 in this case, over 2a, and a is just 1, so we're just going to write 1 there. And then plus or minus the square root of b squared, so 4 squared, minus 4ac, so 4 times 1 times 13, all over 2a. So now if we just expand this a bit, we get -4 halves plus or minus the square root of 16 minus 52 over 2. And so if we do one more computation, we get -2 is x is equal, so we get x is equal to -2 plus or minus, and then 16 minus 52 is -36. And so now we have a negative number underneath the radical. So what do we do with that? Well, what we do is we rearrange it. So just like I showed in the previous segment, what we're going to do is we're going to turn this into -1 times square root of -1 times the square root of 36. Alright? And so now what we have is the square root of 36 that can be simplified. So we have, I'm just going to move this up here. And so now we have x equals -2 plus or minus the square root of 36, so that's 6 times the square root of 1 over 2, which simplifies to x equals -2 plus or minus 3, and then you can rewrite the square root of -1 as I. And so these are so your two imaginary solutions. This is the formula that gives you your two imaginary solutions. So you have one imaginary solution is -2 plus 3i, and your other imaginary solution is -2 minus 3i. So these are imaginary solutions here. Alright, so our next problem that we're going to be doing today is 4x squared plus 8x plus 5 equals 0. And what we want to find are the two roots or the two solutions to find when this supposedly touches the y-axis. Supposedly because this is going to yield some imaginary solutions. Alright? So, again, I'm just going to write the quadratic formula. X equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And remember, this is for your generic quadratic formula equation. Ax squared plus bx plus c. Alright, so for this right here, we have a equal to 4, b equal to 8, and c equal to 5. Alright, so now we just simply plug this in. So to get our two roots, or two solutions, what we do is just plug it right in. So we have b equal to 8, so we have negative b, so negative 8 over 2a, so this is 2 times 4, plus or minus the square root of b squared, so this is 8 squared, so 8 squared, minus 4 times a, so that's times 4, times c, which is times 5, all over 2a, which is 2 times 4. And so now we're just going to expand this out a little bit. So we have negative 8 over 8 plus or minus 64 minus 80 over 8. And so this yields negative 1 plus or minus, and 64 minus 80, that's negative 16. So now we have negative 1 plus or minus the square root of negative 16 over 8. And right now we can see that we can't have a negative number inside a radical, so we have to do something about it. So what we do is, just using the properties of square roots, imaginary numbers, we rewrite this as square root of negative 1 times the square root of 16 over 8. I'm just going to move it back up over here. And now what we can do is we can just rewrite this as negative 1 plus or minus 4 over 8 times the square root of negative 1. And then we can just take this one more step, and we now have, you can rewrite this as I over 2, because I comes from the square root of negative 1, and 4 over 8 is 1/2, so I over 2. So our two solutions are x equals 1, negative 1, plus I over 2, and our other solution is x equals negative 1 minus I over 2. So here are our two solutions with imaginary numbers. Alright, so now let's go on to our next example. So again, the reason why I have so many examples in my videos is just to really drill in the procedure into your mind. Now, if you're all set, or if you want to just pause the video to make sure to use this final problem as a test, feel free. But if you feel like you're good, you don't have to keep watching. I'm not going to do anything new or profound later in this video. So basically, what we have here is our final problem. 2x squared plus 2x plus 13 equals 0. And what we want to do is we want to find the two solutions, or the two roots of this equation. So to do that, we just use our quadratic formula, and I'm just going to write that again up here. Plus or minus a square root of b squared minus 4ac over 2a. And what we have here, and this is for a generic quadratic equation, ax squared plus bx plus c. Alright, so right now we have a equals 2, b equals 2, and c equals 13. Alright, so what we're going to do is we're just going to plug it in to our quadratic formula here. So we have x equal to negative b over 2a, so 2a is 2 times 2, plus or minus the square root of b squared minus 4ac, so you have 2 squared minus 4 times a times c, all over 2a, so 2 times 2. Alright, so now we have x is equal to negative 2 over 4, plus or minus the square root of 4 minus, and this is 8 times 13, which is equal to, let me do a little mental math. Alright, so 104, and that's over 4. So now what we need to do is we need to take x, and what we're going to do is, okay, so this equals negative 1/2 plus or minus, and this is minus 100, or negative 100 over 4, so square root of negative 100 over 4. And again, what we need to do is we just need to rewrite this. So what we do is we take this and we write it like this. And now I'm just going to bring it over here. And now what we can do is, okay, we can just rewrite this as 10 times the square root of negative 1 over 4. And now just to simplify it one more step, we have 5i over 2. So our two solutions are negative 1/2 plus 5i over 2. And our other solution is negative 1/2 minus 5i over 2. So there you go. Hopefully this gives you a good fundamental understanding of how these imaginary solutions work. And the thing is if you're like, man, I'm not sure if I'm really sure there are x-intercepts for all of these quadratic equations. Feel free just to graph them, and you'll see that they don't touch the x-axis. That might be an interesting activity for you to do on your own. If you have any questions or comments, just feel free to write something below. And hopefully this has helped you. So thank you for watching.